Let's solve a fun problem called the toppled square problem. In this diagram, the given values are areas of squares. We need to find the area of the largest square. Pause the video now if you want to try it yourself. Alright, let's get to solving. First, we need to find the side length of the three stacked squares. For the top square, we know that area is side square and is given as 3. Taking the square root of both sides gives us a side length of root 3. We can set up the same equation where area is 12. This gives us a side length of root 12. 12 can be broken into 4 times 3. We can split the radicals into root 4 times root 3, and the value ends up being 2 times the square root of 3. For the bottom square, we set up the equation with area equaling 27. Then, taking the square root of both sides gives us root 27. We can follow the same process as the middle square to reduce it down to 3 times the square root of 3. Let's take these values and add them to our diagram. I'll actually remove the area values from the diagram because we don't need them anymore. Let's also mark some points on our diagram while we're at it. Let's take a closer look at this triangle BCD. We'll pull it out of the diagram, label the vertices, and mark it as a right triangle. We know that the height of this triangle, CD, is 2 times the square root of 3 from before, and we'll move around a couple labels in our diagram to make it easier to find BC. BC is simply BF minus CF. Fortunately, these are side lengths that we already found. BF is 3 times the square root of 3, and CF is 2 root 3. 3 root 3's minus 2 root 3's is just 1 root 3. So let's take this root 3 and label the base of our triangle. Next, we need to find the hypotenuse by using the Pythagorean Theorem. On the left, we enter our hypotenuse, which is BD, and on the right, we enter the triangle sides, which are BC and CD. We know these values to be root 3 and 2 root 3 from our diagram above. Root 3 squared makes 3, and 2 root 3 squared makes 4 times 3. So BD squared is 15, and taking the square root of both sides gives us a value for BD of root 15. Let's add root 15 to our triangle. Next, we have another triangle that we can look at highlighted in purple. Let's pull that one out to take a closer look. Notice that I gave the right angle a label of G for later calculations. The hypotenuse of this triangle is actually one of the sides of the squares that we're interested in. Also, the height, EG, is the sum of the side lengths of the stacked squares from our diagram. The green triangle and the purple triangle are similar triangles, so their side lengths are proportional to each other. The ratio of the hypotenuses is the same as the ratio of the heights, so we'll plug in the values from our triangles into the similar triangle formula. Adding together the numerator of the right side gives us 6 root 3. In 6 root 3 over 2 root 3, the root 3's cancel out. We'll also combine the division on the left side of the equal sign into one radical, giving us root of the quantity x over 15 equals 3. Squaring both sides gives us x over 15 equaling 9, and multiplying both sides by 15 gives us x equaling 9 times 15, which is ultimately 135. And that's our answer. That's the area of the square x. Let me know how you did in the comments, and be sure to subscribe for more math videos. Thanks, and see you next time.